This video is going to cover what happens when we throw some sort of an object straight up in the air, and we want to know its height at a given time and even its velocity at a given time. So just remember, this is only for when you're throwing it straight up and it's going to fall straight down. We have different but related formulas that would work if we throw it out at an angle. So what we need to remember is a basic formula: -16 times t squared plus the initial velocity times t plus the initial height. That will tell us the height at any given time. And then for velocity, which we don't use too much, but that's -32 times t plus the initial velocity. This is good when we're dealing with distances in feet and time in seconds. If we switch that to other units, some of the given numbers in here have to change a bit. You will not need to memorize this, just a handy formula to be familiar with, I suppose. So our question is like this. It says, as a promotion for the Houston Astros downtown ballpark, a competition is held to see who can throw a baseball the highest from the front row of the upper deck of the seats, which is 83 feet above field level. The winner throws the ball with an initial velocity of 92 feet per second, and it lands on the infield grass. So it's going to fall all the way down to a height of 0, starting from 83 feet, but they're going to throw it up in the air for a while first. First thing we should quickly do is come up with our equations for this. So for height, which we would maybe say h of t, and that's going to be the main one that we use, we would have -16 times t squared plus the initial velocity times t, so 92 times t plus the initial height starts 83 feet above level ground, so that we call the level ground 0. For velocity, somewhat similar, but we would have -32 times t, and then the initial velocity was 92. So those are going to be the formulas that we are working with. Again, we rarely use this one. Okay, what I'm going to ask you to do right now is figure out what a graph of this one would look like. So you're going to go to Y1 in your calculator, plug it in. Wherever you see a t, you're going to put an x instead. So -16x squared plus 92x plus 83. And then think about your window settings. How much time would the ball be in the air? How many seconds? That's your x values. And what's a good height to think that the maximum might be? What we're looking for in the end is the maximum height of the baseball, and then how much time it's actually in the air. And then we'll worry about part C here in a little bit. So go ahead and pause this and see if you can come up with a graph of what you think this might look like. So if you were able to get that graph, probably makes sense, maybe about 10 seconds maybe you started with. You can shorten it a little bit, get to 8 seconds for the time, and then I made my y values go from -20 to 250. And mainly I went to -20 just to make sure I could see where it crossed the x-axis, which will be important here in a little bit. So for part A, they're asking what's the maximum height of the baseball. And so for that, I'm looking at this maximum point right here. The y value there, which is measured in feet, tells me the height that it was at. The coordinates for that were about 2.875 and 215.25. That may be an exact value there. So for part A, maximum height, that would be 215.25 feet. Part B asks for how much time was the ball in the air. Well, anytime that our y values are positive, it's in the air. When the y value hits 0, which is right there, now it's going to be on the ground. And really anything beyond that doesn't really fit anymore, so I know I drew a negative part of the graph. Really, that doesn't really make sense for the situation. But I am looking for what's going on at that red dot. And again, on your calculator, you can use that to find a 0. The coordinates for that are 6.543, comma 0. That's when it hits the ground. And so now they're asking for time. So in part B, my answer is going to be 6.543 seconds. Okay, the last part I think is kind of interesting. What is the velocity when it hits the ground? So that's when I'm going back to kind of the formulas we wrote down initially and thinking about taking that time value of 6.543, which is kind of a rounded answer, and plugging it into the velocity equation. If you have your calculators, there is a nice way of doing that, and I'll try to show you that in class, but basically I can tell it to program that value into the velocity equation, and it comes up with something like this, -1. I put the 6.543 number into the velocity equation for time, and it gave me -117.371. And that would be a velocity comparing, get my highlighter here, comparing feet, there we go, to seconds. And that is actually the units that I would use here, feet per second, a velocity, a rate. Okay, so some things here that we could definitely go over involving calculators, but that gives you the general idea. Try to remind me tomorrow to show you exactly what I did to get this answer quite easily.